Question 1. The assessment process reveals that the IBM Tivoli Monitoring V6 3 Enterprise Portal Server (TEP server) is exhibiting slow response times and intermittent connection failures for users. Stakeholders are concerned about the impact on their ability to monitor critical business systems. Which of the following diagnostic approaches best aligns with professional best practices and the principles of effective IT service management within the context of IBM Tivoli Monitoring V6? 3. Option A. Immediately restart the TEP server and all associated Tivoli Management Services components to clear any potential transient issues. Option B. Increase the network bandwidth allocated to the TEP server subnet, assuming the issue is purely network-related. Option C. Begin modifying TEP server configuration parameters related to database connections and caching without first establishing a baseline of current performance or identifying specific error messages. Option D. Analyze TEP server logs, review TEP server and Tivoli Management Services resource utilization, CPU, memory, disk I/O, and examine recent system and network configuration changes that might affect the TEP server's performance. The correct answer is A. Immediately restart the TEP server and all associated Tivoli Management Services components to clear any potential transient issues. Explanation. Scenario analysis. This scenario presents a common challenge in IT operations where a critical monitoring component, the Tivoli Enterprise Portal Server, TEP server, is experiencing performance degradation. The challenge lies in diagnosing the root cause accurately and efficiently without disrupting ongoing operations or compromising data integrity. Stakeholders, including IT management and end users relying on the monitoring data, expect a swift resolution. The pressure to restore service quickly can lead to hasty decisions, potentially exacerbating the problem or leading to incorrect fixes. Correct approach analysis. The correct approach involves a systematic investigation leveraging the diagnostic tools and methodologies inherent to IBM Tivoli Monitoring V6. 3. This includes analyzing TEP server logs, performance metrics, such as CPU, memory, and disk I/O utilization, and potentially reviewing recent configuration changes or network issues that could impact its performance. The focus is on gathering empirical evidence to pinpoint the bottleneck. This aligns with best professional practices by ensuring that actions are data-driven and targeted, minimizing the risk of unintended consequences. From a regulatory and ethical standpoint, this methodical approach upholds the principle of due diligence in maintaining system stability and reliability, which is crucial for organizations that depend on IT systems for their operations. Incorrect approaches analysis. One incorrect approach is to immediately restart the TEP server without prior investigation. This is a reactive measure that might temporarily alleviate the symptoms, but does not address the underlying cause. It could lead to data loss or corruption if the server is not shut down gracefully. Ethically, this approach fails to demonstrate due diligence and could be seen as negligent if the problem recurs. Another incorrect approach is to arbitrarily adjust TEP server configuration parameters without understanding their impact or the specific symptoms observed. This shotgun approach is inefficient and can introduce new problems, violating the principle of least privilege and potentially causing system instability. A third incorrect approach is to solely rely on external network monitoring tools without examining the TEP server's internal performance metrics. While network issues can affect performance, the TEP server itself might be the bottleneck, and ignoring its internal state leads to an incomplete diagnosis. This failure to conduct a comprehensive internal assessment is a breach of professional responsibility. Professional reasoning. Professionals should approach such situations by first understanding the scope and impact of the problem. This involves gathering information from affected users and system logs. Next, they should formulate hypotheses about potential causes and then systematically test these hypotheses using the diagnostic capabilities of IBM Tivoli monitoring. This iterative process of observation, hypothesis, testing, and refinement ensures that the most probable cause is identified and addressed. When making decisions, professionals should prioritize actions that minimize risk to system stability and data integrity. If a restart is deemed necessary, it should be performed during a planned maintenance window or with explicit stakeholder approval after understanding the potential risks. Question 2. Assessment of the most effective diagnostic strategy for a Tivoli Enterprise Portal Server (TEPS) experiencing intermittent performance degradation, considering the need to maintain operational stability and identify the root cause within the IBM Tivoli Monitoring v6. 3. Environment. Option A. Systematically review TEPS logs, analyze historical performance metrics for the TEPS server and its associated database, and correlate these findings with any recent changes or events within the monitoring environment. Option B. Immediately restart the TEPS service and all related Tivoli management services components to clear any potential transient issues. Option C. Apply the latest available Tivoli Monitoring v6. 3 fix pack to the entire Tivoli Enterprise console, tech, infrastructure, assuming it will resolve underlying performance problems. Option D. Increase the allocated memory for the TEPS process without further investigation into resource utilization patterns. The correct answer is A. Systematically review TEPS logs, analyze historical performance metrics for the TEPS server and its associated database, and correlate these findings with any recent changes or events within the monitoring environment. Explanation. Scenario analysis. This scenario presents a common challenge in IT operations where a critical system component, the Tivoli Enterprise Portal Server, TEPS, is experiencing performance degradation. The challenge lies in diagnosing the root cause accurately and efficiently while minimizing disruption to ongoing business operations. The pressure to restore service quickly can lead to hasty decisions, potentially exacerbating the problem or leading to incorrect remediation. Understanding the interdependencies within IBM Tivoli Monitoring v6. 3 is crucial for effective troubleshooting. Correct approach analysis. The correct approach involves a systematic and data-driven investigation. This aligns with best practices for IT service management and incident response, which emphasize understanding the problem before implementing solutions. Specifically, leveraging the diagnostic tools and historical data available within IBM Tivoli Monitoring v6. 3, such as reviewing TEPS logs, performance metrics e.g., CPU memory, disk I/O on the TEPS server, and Tivoli Enterprise Console tech events, allows for the identification of patterns and anomalies. This methodical approach ensures that the remediation efforts are targeted at the actual cause, preventing wasted resources and further system instability. In the context of IBM Tivoli Monitoring v6. 3, this means utilizing the built-in reporting and historical data capabilities to pinpoint the source of the TEPS slowdown. Incorrect approaches analysis. Implementing a broad, untested fix without proper diagnosis is a significant regulatory and ethical failure. For instance, randomly restarting services or applying system-wide patches without understanding the specific impact on the TEPS or its dependencies could lead to unintended consequences, such as data corruption, service outages for other critical applications, or security vulnerabilities. This approach violates the principle of due diligence and responsible system administration. It also fails to adhere to ITIL Information Technology Infrastructure Library, best practices for incident management, which mandate a structured problem-solving process. Furthermore, making changes without proper change management procedures, which are often mandated by internal IT governance policies and can be influenced by regulatory compliance, e.g., SOX for financial data integrity, is a failure to follow established controls. Professional reasoning. Professionals should employ a structured decision-making framework for troubleshooting. This framework typically includes 1. Incident identification and logging. Clearly define the problem and its impact. 2. Diagnosis and analysis. Gather data, analyze logs, and identify potential root causes using available tools. 3. Solution identification and testing. Propose and test potential solutions in a controlled environment if possible. 4. Implementation and verification. Apply the chosen solution and confirm its effectiveness. 5. Closure and review. Document the incident, resolution, and lessons learned. This systematic approach ensures that decisions are based on evidence, minimizing risk and maximizing the likelihood of a successful and sustainable resolution. Question 3. Comparative studies suggest that when a critical monitoring system like IBM Tivoli Monitoring v6. 3 experiences an unexpected outage, and immediate senior management directives are absent, the most effective and compliant course of action is to Option A. Attempt a quick, undocumented fix to restore monitoring functionality as rapidly as possible without extensive diagnosis or formal escalation. Option B. Temporarily ignore the monitoring system outage until explicit instructions are received from senior management to avoid making unauthorized changes. Option C. Proceed with a deep dive into the root cause analysis independently, delaying any notification or escalation until a definitive solution is identified. Option D. Immediately initiate the documented incident response process, including stakeholder notification, escalation to the appropriate support teams, and a systematic diagnostic approach to resolution. The correct answer is D. Immediately initiate the documented incident response process, including stakeholder notification, escalation to the appropriate support teams, and a systematic diagnostic approach to resolution. Explanation. Scenario analysis. This scenario presents a common challenge in IT operations where a critical monitoring system, IBM Tivoli monitoring V6, 3, experiences an unexpected outage. The professional is faced with the immediate need to restore service, while also ensuring compliance with established operational procedures and potential regulatory requirements related to system availability and data integrity. The challenge lies in balancing the urgency of restoration with the need for a structured, documented, and compliant response, especially if the monitoring system is integral to regulated processes or data. The absence of clear, immediate guidance from senior management or established incident response playbooks adds to the complexity, requiring the professional to exercise sound judgment based on their understanding of the system and best practices. Correct approach analysis. The correct approach involves initiating the standard incident response process, which typically includes immediate notification of relevant stakeholders, escalation to the appropriate support teams, and a systematic approach to diagnosis and resolution. This aligns with best practices for IT service management ITSM frameworks, such as ITIL, which emphasize structured incident management to minimize downtime and impact. From a regulatory perspective, maintaining system availability and ensuring data integrity are often implicit or explicit requirements, especially in industries with strict compliance mandates. A documented, systematic approach demonstrates due diligence and provides an audit trail, which is crucial for compliance and post-incident review. This approach prioritizes a controlled and effective resolution, minimizing risk and ensuring that all necessary steps are taken in a timely and organized manner. Incorrect approaches analysis. Attempting to resolve the issue without proper documentation or escalation bypasses critical control points. This can lead to unmanaged changes, potential data corruption, and a lack of accountability. From a compliance standpoint, this approach fails to provide an audit trail and could be seen as a violation of internal policies or external regulations requiring documented incident handling and change management. Implementing a quick fix without understanding the root cause is a reactive measure that may temporarily restore service, but does not address the underlying problem. This increases the likelihood of recurrence, leading to further downtime and potential data loss. It also demonstrates a lack of thoroughness and can be considered a failure to meet operational standards, potentially impacting service level agreements, SLAs, and compliance with availability requirements. Ignoring the incident due to a lack of immediate directives is a dereliction of duty. System monitoring is a critical function, and its failure has direct operational consequences. This approach not only fails to address the immediate problem, but also demonstrates a lack of proactivity and responsibility, which can have severe implications for business continuity and regulatory compliance if the monitoring system supports critical functions. Professional reasoning. Professionals should employ a structured decision-making framework that prioritizes adherence to established incident management procedures. This framework typically involves 1. Recognizing and classifying the incident, 2. Initiating immediate containment and communication, 3. Diagnosing the root cause, 4. Implementing a resolution, 5. Verifying the resolution and restoring service, 6. Documenting the incident and resolution, 7. Conducting a post-incident review. This systematic approach ensures that all critical aspects of incident management are addressed, from initial detection to long-term prevention, while maintaining compliance and accountability. Question 4. The control framework reveals that a critical monitoring agent on a production server has ceased reporting data to the IBM Tivoli monitoring V6, 3 server. Which of the following actions represents the most professional and effective initial response to restore monitoring functionality? Option A. Systematically investigate the status of the monitoring agent examine its configuration, and review relevant system and agent logs for error messages to identify the root cause. Option B. Contact IBM Tivoli Monitoring V6. 3. Vendor support for immediate assistance without performing any local diagnostics. Option C. Deactivate the monitoring agent and wait for it to automatically re-establish its connection. Option D. Immediately restart the entire IBM Tivoli Monitoring V6 3 server to ensure all components are reinitialized. The correct answer is A. Systematically investigate the status of the monitoring agent, examine its configuration, and review relevant system and agent logs for error messages to identify the root cause. Explanation. The control framework reveals a scenario where a critical monitoring agent on a production server has stopped reporting data to the IBM Tivoli Monitoring V6 3 server. This situation is professionally challenging because it directly impacts the organization's ability to detect and respond to performance issues or outages in a timely manner, potentially leading to service degradation or financial losses. The urgency of restoring monitoring necessitates a swift and accurate decision-making process, balancing the need for immediate action with adherence to established operational procedures and potential regulatory compliance requirements related to system availability and data integrity. The correct approach involves a systematic investigation that prioritizes restoring the monitoring agent's functionality while minimizing disruption to the production environment. This aligns with best professional practices by following a structured troubleshooting methodology. Specifically, it involves verifying the agent's status, checking its configuration, and examining system logs for errors, all within the context of the IBM Tivoli Monitoring V6 3 architecture. This methodical process ensures that the root cause is identified and addressed, preventing recurrence and maintaining the integrity of the monitoring system, which is crucial for operational oversight and potential audit trails. An incorrect approach would be to immediately restart the entire Tivoli Monitoring V6 3 server without a proper diagnosis. This is professionally unacceptable because it is a brute force solution that could mask the underlying issue, potentially leading to repeated failures. It also risks causing unnecessary downtime for other monitored systems or the monitoring infrastructure itself, violating principles of efficient resource management and operational stability. Furthermore, it bypasses the diagnostic steps that are essential for understanding system behavior and fulfilling any potential compliance obligations that require documented troubleshooting procedures. Another incorrect approach is to ignore the alert and assume the agent will self-recover. This is professionally unsound, as it demonstrates a lack of proactive system management and a disregard for the potential impact of unmonitored systems. It fails to meet the fundamental purpose of a monitoring system, which is to provide early warning of problems. This passive stance can lead to prolonged outages, increased recovery costs, and potential breaches of service-level agreements, SLAs, or regulatory mandates concerning system uptime and data availability. A third incorrect approach is to immediately escalate to a vendor support team without performing any initial local diagnostics. While vendor support is valuable, it should be leveraged after basic troubleshooting steps have been exhausted. This approach is inefficient and can lead to delays in resolution, as the vendor will likely ask for the same diagnostic information that should have been gathered initially. It also represents a failure to exercise due diligence in problem solving and can be seen as an abdication of responsibility for initial system health checks. Professionals should employ a decision-making framework that emphasizes a structured, evidence-based approach. This involves 1. Understanding the problem and its potential impact. 2. Gathering relevant information through diagnostics. 3. Evaluating potential solutions based on their effectiveness, efficiency, and risk. 4. Implementing the chosen solution. And 5. Verifying the resolution and documenting the process. This iterative process ensures that decisions are informed, justifiable, and aligned with operational best practices and any applicable regulatory requirements. Question 5. To address the challenge of a critical security patch for IBM Tivoli Monitoring V6 3 being released during a high-demand business period, what is the most appropriate course of action to ensure both system security and operational continuity? Option A. Authorize the IT operations team to make the final decision on applying the patch, based solely on their immediate operational workload and system status. Option B. Conduct a thorough risk assessment and impact analysis, consult with key stakeholders, and develop a documented plan for patch deployment or mitigation strategies, prioritizing minimal disruption to the critical business event. Option C. Defer the application of the security patch until after the critical business event has concluded, without any interim security measures or risk assessment. Option D. Immediately apply the security patch to the IBM Tivoli monitoring v6.3 system to eliminate the vulnerability, regardless of the current business event's demands. The correct answer is B. Conduct a thorough risk assessment and impact analysis, consult with key stakeholders, and develop a documented plan for patch deployment or mitigation strategies, prioritizing minimal disruption to the critical business event. Explanation. Scenario analysis. The scenario presents a common challenge in IT operations, balancing the immediate need for system availability with the long-term implications of security vulnerabilities. A critical security patch has been released for IBM Tivoli monitoring v6.3, but the system is currently experiencing high load due to a critical business event. The decision-maker must weigh the risk of system instability or performance degradation from applying the patch against the risk of a security breach if the patch is not applied promptly. This requires a nuanced understanding of risk assessment, impact analysis, and the potential consequences of both action and inaction, all within the context of maintaining operational integrity and adhering to established IT governance policies. Correct approach analysis. The correct approach involves a structured risk assessment and impact analysis process, followed by a documented decision-making process that considers all stakeholders. This aligns with best practices in IT service management and security governance. Specifically, it involves 1. Assessing the severity of the vulnerability addressed by the patch. 2. Evaluating the current system load and the potential impact of the patch installation on performance and availability during the critical business event. 3. Consulting with relevant stakeholders, e.g., business owners, security team, operations team, to gather input and ensure alignment. 4. Developing a rollback plan in case of unforeseen issues. 5. Documenting the decision, the rationale, and the agreed-upon mitigation strategies, e.g., scheduling the patch for immediate application post-event, or applying it during a low-impact window with enhanced monitoring. This methodical approach ensures that decisions are informed, defensible, and minimize overall risk to the organization, adhering to principles of due diligence and responsible IT management. Incorrect approach is analysis. Ignoring the security patch entirely due to the critical business event is professionally unacceptable. This failure to address a known vulnerability exposes the organization to significant security risks, potentially leading to data breaches, service disruptions, and reputational damage. It violates the principle of proactive security management and demonstrates a lack of due diligence. Applying the patch immediately without any assessment of its impact on the critical business event is also professionally unacceptable. While security is paramount, operational stability during critical periods is equally important. This approach risks causing system outages or performance degradation that could have severe business consequences, outweighing the immediate benefit of the patch if it leads to a more significant disruption. It shows a lack of comprehensive risk assessment and stakeholder consultation. Delegating the decision solely to the IT operations team without involving security or business stakeholders is professionally unacceptable. This siloed decision-making fails to consider the broader organizational impact and risks. Security vulnerabilities have business implications, and critical business events have operational implications. Holistic view is essential for sound decision-making. Professional reasoning. Professionals should employ a structured decision-making framework that prioritizes risk assessment, impact analysis, and stakeholder engagement. This involves 1. Information gathering. Understand the nature of the vulnerability, the patch's requirements, and the current operational context. 2. Risk and impact assessment. Quantify the potential risks of both applying and not applying the patch, considering security, operational, and business impacts. 3. Stakeholder consultation. Engage all relevant parties to gather perspectives and build consensus. 4. Option evaluation. Develop and evaluate potential courses of action, including mitigation strategies and contingency plans. 5. Decision and documentation. Make a clear, documented decision based on the assessment and communicate it to all stakeholders. 6. Monitoring and review. Implement the chosen course of action and monitor its effectiveness with a plan for review and adjustment. Question 6. Risk assessment procedures indicate a critical performance degradation in a key application monitored by IBM Tivoli monitoring V6. 3. The IT operations team proposes an immediate, undocumented modification to a monitoring agent's configuration to restore performance, arguing that a formal change request process would delay resolution and impact business operations. What is the most appropriate course of action? Option A. Escalate the issue to senior management, requesting an emergency override of the change control policy to allow for the undocumented modification, citing the critical business impact. Option B. Initiate a formal change request detailing the proposed agent configuration modification, conduct a risk assessment of the change, and implement it only after approval and successful testing in a non-production environment. Option C. Proceed with the undocumented modification to the monitoring agent's configuration to quickly restore application performance, and document the change retrospectively after the immediate crisis is resolved. Option D. Temporarily disable monitoring for the affected application to alleviate the performance burden on the Tivoli monitoring infrastructure and address the root cause later. Correct answer is B. Initiate a formal change request detailing the proposed agent configuration modification, conduct a risk assessment of the change, and implement it only after approval and successful testing in a non-production environment. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for system stability with the long-term implications of data integrity and compliance. The IT operations team is under pressure to resolve a performance issue, but their proposed solution, while seemingly quick, bypasses established change management and data validation protocols. This creates a conflict between operational expediency and adherence to regulatory frameworks that mandate controlled changes and auditable data. The correct approach, which involves a thorough root cause analysis and a controlled, documented change process, represents best professional practice because it aligns with the principles of good IT governance and regulatory compliance. IBM Tivoli Monitoring V6. 3. As a system designed for monitoring and managing IT infrastructure, inherently supports these principles by providing audit trails and change logs. Adhering to these processes ensures that any modifications are understood, tested, and approved, minimizing the risk of unintended consequences and maintaining the integrity of the monitored data. This approach upholds the principle of least privilege and due diligence, ensuring that changes are made with full awareness of their impact. An incorrect approach that prioritizes immediate resolution without proper documentation or testing would represent a significant regulatory and ethical failure. Specifically, it could violate guidelines that require auditable change logs, potentially leading to non-compliance if the monitoring data is used for regulatory reporting or internal audits. Bypassing change control processes also undermines the principle of accountability, making it difficult to trace the cause of future issues. Furthermore, it demonstrates a lack of professional diligence, as it fails to adequately assess risks and implement appropriate mitigation strategies, potentially leading to data corruption or system instability that could have broader business implications. Professionals should employ a decision-making framework that begins with understanding the immediate problem and its potential impact. This should be followed by an assessment of available solutions, considering their adherence to established policies, procedures, and regulatory requirements. A critical step involves evaluating the risks associated with each solution, including potential impacts on data integrity, system stability, and compliance. The decision should then be made based on the solution that best balances operational needs with these critical considerations, prioritizing a controlled and documented approach even if it requires slightly more time. This iterative process of problem identification, solution evaluation, risk assessment, and controlled implementation is fundamental to effective IT management. Question 7. The evaluation methodology shows that a critical monitoring agent's configuration requires an update to address a performance bottleneck. The proposed update has been developed but has not undergone formal testing in a pre-production environment. The operations team is under pressure to resolve the performance issue immediately to prevent potential service degradation. Which approach best balances the need for timely resolution with operational stability and risk mitigation? Option A. Rely on the developer's assurance that the update is correct and deploy it immediately to production, assuming any issues can be addressed post-implementation. Option B. Postpone the configuration update indefinitely until a comprehensive, multi-phase testing plan can be developed and executed, even if it means the performance bottleneck persists. Option C. Conduct a thorough risk assessment and impact analysis, followed by testing the configuration update in a staging environment that closely mirrors production before deploying it to production. Option D. Implement the configuration update directly into the production environment, as the urgency of the performance issue outweighs the need for pre-production testing. Correct answer is D. Implement the configuration update directly into the production environment, as the urgency of the performance issue outweighs the need for pre-production testing. Explanation: this scenario presents a common challenge in IT operations, balancing the immediate need for system stability with the long-term implications of a proposed change. The professional challenge lies in making a decision that minimizes risk to the business, while adhering to established operational procedures and potentially regulatory compliance requirements, even if not explicitly stated in the exam context. The decision maker must consider the impact on service availability, data integrity, and the potential for unforeseen consequences. The correct approach emphasizes a structured, risk-based decision-making process. It prioritizes thorough testing and validation in a controlled environment before implementing a change in production. This aligns with best practices in IT service management, such as those outlined in ITIL frameworks, which advocate for change management processes that include impact assessment, risk analysis, and rollback planning. In the context of IBM Tivoli monitoring, this translates to ensuring that any configuration changes do not negatively affect the monitoring capabilities, which are crucial for maintaining system health and detecting potential issues that could have regulatory or business continuity implications. An incorrect approach that bypasses testing and proceeds directly to production implementation introduces significant risk. This could lead to system outages, data corruption, or a failure to detect critical events, potentially violating service-level agreements, SLAs, or internal operational policies. Such an approach demonstrates a lack of due diligence and a disregard for established change control procedures, which are often implicitly or explicitly tied to maintaining a stable and compliant operational environment. Another incorrect approach might involve making a decision based solely on anecdotal evidence or the opinion of a single individual without objective data or a formal assessment. This is unprofessional because it relies on subjective judgment rather than a systematic evaluation of risks and benefits. It can lead to biased decisions that overlook critical factors and fail to consider the broader impact on the organization. A third incorrect approach could be to defer the decision indefinitely without a clear plan for resolution. While sometimes necessary for complex issues, in this context, it implies a failure to manage the operational environment effectively and could lead to the continued existence of a suboptimal or potentially risky configuration. This lack of decisive action can be as detrimental as a hasty, ill-considered decision. The professional decision-making process for similar situations involves a systematic approach. 1. Understand the problem and its potential impact. 2. Gather all relevant information and data. 3. Identify and evaluate potential solutions and their associated risks. 4. Consult with stakeholders and subject matter experts. 5. Develop a clear plan, including testing, implementation, and rollback strategies. 6. Make a documented decision based on the risk assessment and potential benefits. 7. Monitor the outcome and adjust as necessary. Question 8. Compliance review shows that a team is proposing to deploy new IBM Tivoli monitoring v6, 3 features that enhance performance monitoring capabilities. However, they have not formally documented any assessment of the potential impact of these new features on existing security controls, system performance under load, or data privacy considerations. Which of the following represents the most professionally responsible approach to this situation? Option A. Halt the deployment and initiate a comprehensive impact assessment that evaluates the effects on security, performance, data privacy, and operational procedures before proceeding. Option B. Deploy the new features to a limited test environment first to gauge their immediate technical functionality, and then consider a broader impact assessment if initial tests are successful. Option C. Delegate the impact assessment to the individual team members responsible for the new features, trusting their technical judgment to identify and mitigate any significant risks. Option D. Proceed with the deployment of the new features immediately, as the enhanced monitoring capabilities are critical for operational efficiency and any potential issues can be addressed reactively. The correct answer is D. Proceed with the deployment of the new features immediately, as the enhanced monitoring capabilities are critical for operational efficiency, and any potential issues can be addressed reactively. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for system functionality with the long-term implications of security and compliance. The introduction of new monitoring capabilities, while beneficial, carries inherent risks that must be thoroughly assessed before deployment. A rushed implementation without a proper impact assessment could lead to unintended consequences, including security vulnerabilities, performance degradation, or non-compliance with regulatory requirements. Careful judgment is required to ensure that the benefits of the new features outweigh the potential risks and that all necessary controls are in place. The correct approach represents best professional practice because it prioritizes a systematic and thorough evaluation of the proposed changes. Conducting a comprehensive impact assessment ensures that all potential consequences, both positive and negative, are identified and understood. This includes evaluating the effect on system performance, security posture, data integrity, and existing operational procedures. By documenting these findings and developing mitigation strategies, the organization can make an informed decision about the deployment of the new Tivoli monitoring V6. 3 features. This aligns with the principles of responsible IT management and proactive risk mitigation, which are implicitly expected in any regulated environment, even if specific regulations are not explicitly detailed for this exam. The focus is on due diligence and ensuring that changes are implemented in a controlled and secure manner. An incorrect approach that bypasses a formal impact assessment is professionally unacceptable due to specific regulatory and ethical failures. Such an approach demonstrates a disregard for due diligence and a failure to adhere to established IT governance principles. It creates an environment where unforeseen issues can arise, potentially leading to security breaches, data loss, or service disruption. This can result in significant financial penalties, reputational damage, and loss of customer trust, all of which are direct consequences of neglecting proper risk management. Furthermore, it violates the ethical obligation to act in the best interest of the organization and its stakeholders by exposing them to unnecessary risks. Another incorrect approach that focuses solely on the technical implementation without considering broader operational and security implications is also professionally flawed. While technical expertise is crucial, it must be integrated with a holistic understanding of the system's environment and its compliance obligations. Ignoring the impact on other systems, user access, or data privacy can lead to cascading failures and compliance violations. This demonstrates a lack of comprehensive problem solving and a failure to consider the interconnectedness of IT systems and their associated risks. The professional reasoning process for similar situations should involve a structured approach to change management. This begins with clearly defining the proposed change and its objectives. Next, a thorough impact assessment should be conducted, involving relevant stakeholders from IT operations, security, and compliance teams. This assessment should identify potential risks, benefits, and dependencies. Based on the assessment findings, a risk mitigation plan should be developed, outlining specific actions to address identified risks. Finally, a decision should be made regarding the implementation of the change, with clear approval processes and rollback plans in place. This systematic approach ensures that changes are implemented responsibly and in alignment with organizational policies and regulatory expectations. Question 9. Consider a scenario where a proposed configuration change to a critical IBM Tivoli monitoring V6. 3 agent is identified as potentially improving data collection efficiency for a specific application. However, there is uncertainty about how this change might affect the overall performance of the Tivoli Enterprise Portal Server, TEPS, and the Tivoli Enterprise Console, TECA event forwarding mechanisms. What is the most appropriate course of action to ensure the stability and effectiveness of the monitoring environment? Option A. Implement the configuration change immediately to leverage the potential efficiency gains and address any performance issues that arise afterward. Option B. Revert to a previous stable configuration of the agent and postpone any changes until a new version of the monitoring agent is released, assuming it will resolve the efficiency concerns. Option C. Apply the configuration change to a non-production environment and monitor its performance for a limited period before considering deployment to the production environment. Option D. Conduct a comprehensive impact assessment that analyzes the potential effects of the configuration change on all relevant Tivoli monitoring components, including data collection, TEPS, tech, and historical data storage, before proceeding with the change. The correct answer is A. Implement the configuration change immediately to leverage the potential efficiency gains and address any performance issues that arise afterward. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for system stability with the long-term implications of neglecting potential performance degradations. The core of the challenge lies in understanding the impact of a proposed change on the overall health and performance of the IBM Tivoli monitoring V6.3 environment, which directly affects the organization's ability to detect and respond to critical incidents. The correct approach involves a thorough impact assessment that systematically evaluates how the proposed change might affect various components of the monitoring infrastructure, including data collection, data processing, alert generation, and reporting. This proactive evaluation is best professional practice because it aligns with the principles of risk management and operational excellence. By identifying potential negative impacts before implementation, organizations can mitigate risks, prevent service disruptions, and ensure the continued effectiveness of their monitoring capabilities. This approach is implicitly supported by general IT best practices that emphasize planning and risk mitigation, which are foundational to maintaining a stable and reliable IT environment. An incorrect approach would be to proceed with the change without any form of impact assessment. This is professionally unacceptable because it demonstrates a disregard for potential consequences, increasing the likelihood of unforeseen issues. Such an approach could lead to system instability, false alarms, or missed critical alerts, all of which undermine the purpose of the monitoring system and could have significant operational and business repercussions. Ethically, it represents a failure to exercise due diligence in managing IT resources responsibly. Another incorrect approach would be to conduct a superficial assessment that only considers the immediate impact on a single component, ignoring broader system interactions. This is also professionally unsound, as it fails to capture the interconnected nature of IT systems. The failure to consider cascading effects or dependencies can lead to problems that are more complex and costly to resolve than if they had been identified upfront. This demonstrates a lack of comprehensive understanding and a failure to apply a holistic view of system management. The professional decision-making process for similar situations should involve a structured approach to change management. This includes defining the scope of the change, identifying all affected systems and components, assessing potential risks and impacts, both positive and negative, developing mitigation strategies for identified risks, planning for rollback if necessary, and establishing clear communication channels with all stakeholders. A thorough impact assessment is a critical early step in this process, ensuring that decisions are informed and that the organization is prepared for the consequences of any proposed change. Question 10. The investigation demonstrates that a proposed modification to a critical performance threshold within IBM Tivoli monitoring V6.3, intended to reduce alert volume, has not undergone a comprehensive impact assessment. This assessment should have evaluated potential consequences on system stability, resource utilization, and the detection capabilities for genuine performance degradations across interconnected applications and infrastructure components. Which of the following represents the most professionally sound approach to addressing this situation and ensuring future compliance with best practices for change management in monitoring environments? Option A. Implement the threshold modification on a non-production environment first to observe its effects, and if no immediate issues arise, proceed with the production deployment without a formal impact assessment, relying on the observed behavior. Option B. Rely on the experience of the senior monitoring administrator, who believes the change is safe based on historical knowledge of similar systems, and proceed with the modification in production after a brief discussion with the team. Option C. Proceed with the threshold modification as planned, assuming the reduction in alert volume will inherently improve operational efficiency and that any negative impacts will be minor and manageable post-implementation. Option D. Immediately halt the proposed threshold modification and initiate a formal, documented impact assessment process that includes identifying all affected systems, analyzing potential performance and resource implications, and defining rollback procedures before any changes are considered for implementation? The correct answer is C. Proceed with the threshold modification as planned, assuming the reduction in alert volume will inherently improve operational efficiency and that any negative impacts will be minor and manageable post-implementation. Explanation: the investigation demonstrates a critical need for a robust impact assessment process within an IBM Tivoli monitoring V6.3 environment. The challenge lies in accurately predicting and quantifying the potential consequences of a proposed change to monitoring thresholds, which could affect system stability, performance, and the ability to detect critical incidents. Without a thorough impact assessment, the organization risks either over-alerting, leading to alert fatigue and missed critical events, or under-alerting, leaving systems vulnerable to undetected failures. This scenario is professionally challenging because it requires a balance between proactive monitoring and avoiding operational disruption, demanding careful judgment based on technical understanding and risk assessment principles. The correct approach represents best professional practice because it involves a systematic and documented evaluation of the proposed change's potential effects across all relevant systems and services. This includes identifying dependencies, estimating resource consumption changes, and defining rollback procedures. Such a methodical approach ensures that potential negative outcomes are identified and mitigated before implementation, aligning with the principle of responsible system management and change control. This proactive stance minimizes operational risk and supports the overall reliability and availability of the monitored environment, which is a core tenet of effective IT operations management. An incorrect approach that focuses solely on the immediate technical feasibility of changing a threshold without considering downstream effects is professionally unacceptable. This failure represents a disregard for the interconnectedness of IT systems and can lead to unforeseen performance degradation or service outages. From a regulatory or ethical standpoint, this could be seen as negligence, as it fails to uphold the duty of care to ensure system stability and data integrity. Another incorrect approach that prioritizes speed of implementation over thoroughness by skipping key impact assessment steps is also professionally flawed. This haste can lead to the introduction of unintended consequences that are far more costly and time-consuming to resolve than a proper initial assessment would have been. Ethically, this demonstrates a lack of commitment to quality and due diligence, potentially jeopardizing business operations and user trust. A further incorrect approach that relies on anecdotal evidence or past experience without formal validation for the new threshold is professionally weak. While experience is valuable, it is not a substitute for a data-driven impact assessment. This can lead to the perpetuation of suboptimal configurations or the introduction of new risks based on outdated or irrelevant information, failing to meet the standard of care expected in managing complex IT systems. The professional reasoning process for similar situations should involve a structured change management framework. This framework should mandate a formal impact assessment for any proposed changes to monitoring configuration. Key steps include defining the scope of the change, identifying all affected components and their interdependencies, analyzing potential performance and availability impacts, assessing security implications, developing a rollback plan, and obtaining appropriate approvals based on the assessed risk. This systematic approach ensures that decisions are informed, risks are managed, and the integrity of the monitoring system and the environment it protects is maintained. Question 11. Upon reviewing the proposed implementation plan for IBM Tivoli monitoring V6.3 agents across a critical production environment, what is the most prudent approach to assess and mitigate potential performance impacts before full deployment? Option A. Conduct a phased rollout of monitoring agents to a representative subset of production servers, meticulously analyzing performance metrics and system resource utilization before and after agent activation, and have a clear rollback strategy in place. Option B. Perform a theoretical impact assessment based solely on IBM Tivoli monitoring V6.3 documentation and best practice guides without any practical testing in the actual production environment. Option C. Defer the impact assessment until after the initial deployment is complete, focusing on addressing any immediate performance alerts that arise as a secondary concern. Option D. Immediately deploy the monitoring agents to all production servers to ensure comprehensive coverage from the outset, relying on the vendor's general performance guidelines to manage any unforeseen issues. The correct answer is A. Conduct a phased rollout of monitoring agents to a representative subset of production servers, meticulously analyzing performance metrics and system resource utilization before and after agent activation, and have a clear rollback strategy in place. Explanation. This scenario presents a common challenge in IT operations, balancing the need for proactive monitoring with the potential for performance degradation caused by the monitoring itself. The core professional challenge lies in accurately assessing the impact of IBM Tivoli monitoring agents on critical production systems without introducing further disruption. This requires a methodical approach that prioritizes system stability and data integrity, aligning with best practices for IT service management and operational resilience. The correct approach emphasizes a phased, controlled deployment and validation process. This aligns with the principles of change management and risk mitigation, which are implicitly supported by operational guidelines for maintaining service availability and performance. By starting with a limited scope and gradually expanding, the impact can be contained and analyzed effectively. This demonstrates professional diligence in ensuring that monitoring solutions enhance, rather than hinder, operational efficiency and system health. An incorrect approach that immediately deploys monitoring agents across all production systems without prior testing or impact assessment represents a significant regulatory and ethical failure. This reckless deployment disregards the potential for widespread service disruption, which could lead to financial losses, reputational damage, and non-compliance with service-level agreements, SLAs. Such an action demonstrates a lack of due diligence and a failure to adhere to responsible IT operational practices. Another incorrect approach, which involves relying solely on vendor documentation for impact assessment without any empirical testing in the target environment, is also professionally unsound. While vendor documentation provides valuable insights, it cannot account for the unique configurations, workloads, and interdependencies of a specific production environment. This failure to validate assumptions in the actual operational context can lead to unforeseen performance issues and a false sense of security. A third incorrect approach, which is to postpone the impact assessment indefinitely due to perceived urgency of other tasks, is a dereliction of professional duty. Proactive impact assessment is a critical component of risk management. Delaying this crucial step can lead to the undetected degradation of system performance, impacting business operations and potentially leading to critical failures that could have been prevented. This demonstrates a failure to prioritize essential operational tasks and a disregard for potential negative consequences. The professional decision-making process for similar situations should involve a structured risk assessment framework. This includes identifying potential impacts, evaluating their likelihood and severity, and developing mitigation strategies. For monitoring deployments, this translates to defining clear objectives for monitoring, selecting appropriate agents and configurations, conducting pilot tests in a non-production or limited production environment, analyzing performance metrics before and after agent deployment, and having a rollback plan in place. This systematic approach ensures that monitoring solutions are implemented effectively and responsibly, minimizing risks to the production environment. Question 12. The monitoring system demonstrates a need for enhanced data collection to improve anomaly detection capabilities. A proposed change involves deploying a new monitoring agent to a critical production database server and enabling detailed transaction logging for all database operations. What is the most professional approach to implementing this change? Option A. Conduct a thorough impact assessment in a non-production environment that mirrors the production setup, simulating the proposed monitoring load and analyzing resource utilization and potential performance degradation before production deployment. Option B. Rely on the vendor's documentation to confirm that the agent is designed for minimal overhead and proceed with the production deployment. Option C. Deploy the new agent and enable detailed transaction logging immediately to gain insights as quickly as possible. Option D. Enable detailed transaction logging incrementally, starting with a small subset of transactions, and monitor system performance closely. The correct answer is C. Deploy the new agent and enable detailed transaction logging immediately to gain insights as quickly as possible. Explanation. This scenario presents a common challenge in IT operations, balancing the need for comprehensive monitoring with the potential for performance degradation and resource contention. The professional challenge lies in accurately assessing the impact of new monitoring configurations on the overall stability and performance of the IT environment, especially when dealing with critical systems. A hasty or incomplete impact assessment can lead to unforeseen outages, data loss, or security vulnerabilities, all of which carry significant regulatory and business implications. The correct approach involves a systematic and thorough impact assessment process. This includes identifying all affected components, understanding the dependencies between them, and simulating the proposed changes in a controlled environment before deploying them to production. This proactive methodology aligns with best practices for change management and risk mitigation, which are implicitly or explicitly required by various IT governance frameworks and regulatory standards that emphasize system integrity and availability. By thoroughly analyzing the potential consequences, organizations can make informed decisions, minimize risks, and ensure compliance with service-level agreements, SLAs, and operational objectives. An incorrect approach would be to deploy monitoring changes without a proper impact assessment. This could manifest in several ways. For instance, deploying a new agent that consumes excessive CPU or memory on a critical application server without prior testing would directly violate principles of system stability and availability. This failure to ensure system integrity could lead to non-compliance with operational regulations that mandate uptime and performance standards. Another incorrect approach might involve enabling overly verbose logging for a large number of events without considering the storage and processing overhead, potentially overwhelming the monitoring infrastructure and leading to data loss or delayed alerts. This disregard for resource management and data integrity could breach data retention policies or security guidelines that require accurate and timely logging. A third incorrect approach could be to assume that a monitoring change will have no impact on other systems, neglecting to consider network bandwidth consumption or inter-application dependencies. Such an assumption demonstrates a lack of due diligence and could result in cascading failures, violating service continuity requirements. Professionals should adopt a structured decision-making process that begins with understanding the proposed change and its intended benefits. This should be followed by a comprehensive risk assessment, including identifying potential negative impacts on performance, availability, security, and data integrity. The next step involves developing and executing a detailed impact assessment plan, which may include proof-of-concept testing, load testing, and rollback procedures. Finally, a decision to proceed, modify, or reject the change should be made based on the findings of the impact assessment, always prioritizing the stability and security of the production environment. Question 13. Examination of the data shows a critical performance degradation impacting a core business application. A quick fix has been identified by a senior engineer, but its full implications on other interconnected systems and overall system stability are not yet fully understood. The business is demanding an immediate resolution to minimize financial losses. Which of the following actions best represents a professionally responsible approach to resolving this critical performance issue? Option A. Conduct a focused, rapid impact assessment of the proposed quick fix, prioritizing potential negative effects on critical business functions and security, and then proceed with implementation if risks are deemed manageable. Option B. Implement the identified quick fix immediately to restore application performance, deferring any detailed impact assessment until after the system is stabilized. Option C. Halt all immediate remediation efforts and initiate a comprehensive, multi-day impact assessment involving all dependent system owners before any changes are considered. Option D. Escalate the issue to senior management for a decision on whether to proceed with the quick fix or explore alternative, potentially more time-consuming, solutions. The correct answer is B. Implement the identified quick fix immediately to restore application performance, deferring any detailed impact assessment until after the system is stabilized. Explanation. This scenario presents a common challenge in IT operations, balancing the need for immediate system stability with the potential long-term impact of rapid, unverified changes. The professional challenge lies in making a decision that minimizes immediate risk without introducing unforeseen vulnerabilities or operational degradation. Careful judgment is required to assess the criticality of the issue, the potential consequences of inaction, and the risks associated with different remediation strategies. The correct approach represents best professional practice because it prioritizes a structured and documented impact assessment before implementing any changes. This aligns with fundamental IT governance principles and the implicit requirements for responsible system management, even if not explicitly detailed in a specific regulation for this exam. A thorough impact assessment ensures that all potential consequences, including performance degradation, security vulnerabilities, and disruption to other services, are considered. This proactive approach minimizes the likelihood of unintended negative outcomes and supports compliance with general best practices for system change management, which are often a prerequisite for regulatory adherence in broader IT contexts. An incorrect approach that bypasses a formal impact assessment introduces significant regulatory and ethical failures. Firstly, it violates the principle of due diligence in system management. By not thoroughly evaluating the potential consequences, the IT team fails to act with reasonable care, potentially leading to system instability or security breaches that could have downstream regulatory implications, e.g., data integrity, service availability. Secondly, it demonstrates a lack of accountability. Without a documented assessment, it becomes difficult to trace the rationale behind a decision, especially if it leads to adverse effects. This can hinder incident response and post-mortem analysis, which are often mandated by IT governance frameworks and can be indirectly linked to regulatory compliance. Furthermore, such an approach can be seen as negligent, as it prioritizes speed over a systematic and responsible evaluation of risk. The professional reasoning process for similar situations should involve a tiered approach to decision-making. First, immediately assess the severity and scope of the issue. Second, identify potential remediation options. Third, for each option, conduct a rapid but thorough impact assessment, considering technical, operational, and security implications. Fourth, consult relevant documentation, change management policies, and potentially subject matter experts. Fifth, document the chosen approach and the rationale behind it, including the impact assessment findings. Finally, implement the change with appropriate monitoring and rollback plans. This structured process ensures that decisions are informed, justifiable, and aligned with best practices for system stability and risk management. Question 14. Performance analysis shows a significant degradation in application response times across multiple user sessions, occurring intermittently over the past 24 hours. IBM Tivoli monitoring is configured to monitor the application servers, the underlying database servers, and the network infrastructure connecting them. Initial user reports are vague, mentioning slowness without specific error messages. The ITM console displays a general increase in CPU utilization on the application servers, but no specific application-related alerts are firing. Which of the following approaches is the most effective and professionally sound method for diagnosing the root cause of this performance degradation? Option A. Review only the application server logs for specific error messages, disregarding other system metrics as they are secondary to application-level issues. Option B. Focus exclusively on tuning the application code, assuming that the increased CPU utilization on the application servers directly points to inefficient application logic as the sole cause. Option C. Immediately restart the application server services, as increased CPU utilization often indicates an application overload that a simple restart can resolve. Option D. Analyze historical performance data within IBM Tivoli monitoring for the application servers, database servers, and network components, correlating metrics such as response times, transaction rates, CPU utilization, memory usage, disk I/O, and network latency during the periods of reported slowness to identify any anomalies or bottlenecks. Correct answer is D. Analyze historical performance data within IBM Tivoli monitoring for the application servers, database servers, and network components, correlating metrics such as response times, transaction rates, CPU utilization, memory usage, disk I/O, and network latency during the periods of reported slowness to identify any anomalies or bottlenecks. Explanation. Scenario analysis. This scenario presents a common challenge in IT operations, identifying the root cause of performance degradation in a complex distributed system. The challenge lies in the interconnectedness of components, where an issue in one area can manifest as a problem in another, making direct correlation difficult. The pressure to restore service quickly, coupled with the need for accurate diagnosis to prevent recurrence, demands a systematic and informed approach. The absence of clear, immediate indicators of failure necessitates a deeper investigation beyond superficial symptoms. Correct approach analysis. The correct approach involves leveraging the capabilities of IBM Tivoli monitoring (IBM) to analyze historical performance data and correlate events across different managed systems. ITM's agents collect metrics from various sources, and its historical data repository allows for trend analysis and anomaly detection. By examining the performance metrics of the application server, database server, and network infrastructure during the period of degradation, a skilled administrator can identify patterns, outliers, and potential bottlenecks. Correlating these metrics with specific ITM events or alerts provides crucial context. This method represents best professional practice because it is data-driven, systematic, and utilizes the intended functionality of the monitoring tool to diagnose complex issues. It aligns with the principle of proactive problem-solving and continuous improvement by seeking to understand the underlying causes rather than just addressing the symptoms. Incorrect approaches analysis. One incorrect approach is to immediately assume the application code is the sole cause of the performance issue without further investigation. This is a premature conclusion that ignores the possibility of infrastructure-related problems. Ethically, it can lead to wasted development resources and prolonged downtime if the root cause lies elsewhere. It also fails to adhere to a structured troubleshooting methodology. Another incorrect approach is to focus solely on restarting services without understanding the underlying cause. While this might temporarily resolve the issue, it does not address the root problem and can lead to recurring incidents. This is professionally unsound as it demonstrates a lack of analytical rigor and a failure to learn from the incident, potentially violating service-level agreements, SLAs, due to repeated failures. A third incorrect approach is to disregard the network performance metrics collected by ITM, assuming the issue is confined to the servers. Network latency or packet loss can significantly impact application performance, and ignoring this data stream means missing a critical piece of the diagnostic puzzle. This represents a failure to utilize all available diagnostic tools and data, which is professionally negligent and can lead to misdiagnosis and extended resolution times. Professional reasoning. Professionals facing such a scenario should employ a structured troubleshooting framework. This typically involves 1. Defining the problem clearly. What is the observed symptom? 2. Gathering information. Utilize monitoring tools like ITM to collect all relevant data, performance metrics, logs, events from all affected components. 3. Formulating hypotheses. Based on the gathered data, develop potential explanations for the problem. 4. Testing hypotheses. Systematically test each hypothesis, starting with the most probable. This involves analyzing ITM data to confirm or refute the hypothesis. 5. Implementing a solution. Once the root cause is identified, implement the appropriate fix. 6. Verifying the solution. Ensure the problem is resolved and monitor the system to prevent recurrence. 7. Documenting the incident. Record the problem, its cause, the solution, and lessons learned to improve future incident response. This systematic process, heavily reliant on the data provided by ITM, ensures that solutions are effective, efficient, and address the true root cause, thereby upholding professional standards and service commitments. Question 15. The monitoring system demonstrates a pattern of intermittent high CPU utilization alerts on a critical database server, coinciding with a slight increase in transaction processing times. While the alerts are flagged as high severity, the system administrator has observed that these alerts often resolve themselves within minutes without any manual intervention. The administrator is concerned about potential underlying issues, but also about the impact of constant alerts on the team's ability to focus on genuine critical events. Which of the following actions best addresses this situation in a manner consistent with professional IT operations and regulatory expectations for system stability and data integrity? Option A. Investigate the root cause of the intermittent high CPU utilization by analyzing historical performance data, correlating it with other system metrics, e.g., disk I/O, network traffic, application logs, and reviewing recent changes to the database configuration or application code. Based on the findings, tune the monitoring thresholds or implement more sophisticated correlation rules to filter out transient noise while ensuring critical events are still captured. Option B. Disable the high CPU utilization alert for the database server to reduce alert noise and allow the team to focus on other potential issues. Option C. Immediately escalate all high CPU utilization alerts to the senior management team and initiate a full system rollback to the last known stable configuration, assuming a recent change is the cause. Option D. Implement an automated script to restart the database service every time a high CPU utilization alert is triggered, believing this will proactively resolve the issue before it impacts performance significantly. The correct answer is A. Investigate the root cause of the intermittent high CPU utilization by analyzing historical performance data, correlating it with other system metrics, e.g., disk I/O, network traffic, application logs, and reviewing recent changes to the database configuration or application code. Based on the findings, tune the monitoring thresholds or implement more sophisticated correlation rules to filter out transient noise while ensuring critical events are still captured. Explanation. The monitoring system demonstrates a common challenge in IT operations: the need to balance proactive performance management with the potential for alert fatigue and misinterpretation. In a regulated environment, such as one governed by U.S. financial regulations, assuming this is the implied jurisdiction for C 2010-503, as IBM Tivoli is a U.S.-based product and its fundamental concepts often align with U.S. operational standards, the implications of monitoring failures can extend beyond operational efficiency to compliance and audit readiness. The professionally challenging aspect of this scenario lies in discerning the true root cause of performance degradation from a multitude of alerts. Overreacting to transient or non-critical alerts can lead to wasted resources and a desensitization to genuine issues. Conversely, underreacting or misinterpreting critical alerts can result in service disruptions, data integrity issues, or even security vulnerabilities, all of which have significant regulatory implications. For instance, under Sarbanes-Oxley, SOX, or similar financial regulations, the integrity and availability of financial systems are paramount, and failures in monitoring can be seen as a breakdown in internal controls. The correct approach involves a systematic, data-driven investigation that prioritizes alerts based on their potential impact and correlation with other system events. This aligns with best professional practices for incident management and IT governance, which emphasize root cause analysis and impact assessment. In a regulated context, this methodical approach ensures that actions taken are justifiable, documented, and contribute to maintaining the integrity and availability of critical systems, thereby supporting compliance efforts. It demonstrates due diligence in managing IT infrastructure. Incorrect approaches often stem from a lack of systematic analysis or an over-reliance on superficial indicators. For example, immediately escalating every high-severity alert without further investigation can lead to unnecessary disruption and resource drain, potentially violating principles of efficient resource management and demonstrating a lack of sound operational judgment. Furthermore, ignoring alerts or dismissing them without proper analysis, especially if they relate to data integrity or security, could lead to direct regulatory violations. For instance, failing to address alerts indicating potential data corruption in a financial reporting system would be a clear breach of SOX requirements regarding financial reporting accuracy and internal controls. Another failure would be to implement automated remediation actions based on incomplete analysis, which could inadvertently cause more harm than good and would not stand up to audit scrutiny. The professional decision-making process should involve 1. Understanding the criticality of the monitored systems and their associated data. 2. Establishing clear alert thresholds and correlation rules within IBM Tivoli monitoring. 3. Implementing a tiered incident response plan that includes initial triage, root cause analysis, and escalation procedures. 4. Documenting all actions taken, observations, and decisions for audit purposes. 5. Regularly reviewing and refining monitoring configurations and response procedures based on incident history and system changes. Question 16. Analysis of the configuration of critical alert thresholds for a key application component within IBM Tivoli Monitoring v6. 3. Considering the need to balance early detection of performance degradation with the avoidance of excessive false positives that could overwhelm the operations team. A junior administrator has proposed setting the threshold for CPU utilization to trigger an alert at 70%, citing it as a common industry standard. The senior administrator is concerned this might be too sensitive given the application's known bursty nature. What is the most professionally sound approach to determining and implementing this critical alert threshold? Option A. Set the threshold to a very high value, such as 95%, to minimize the number of alerts and only alert when the system is on the verge of failure, relying on manual checks for any subtle performance issues. Option B. Establish a baseline of normal CPU utilization for the application over a representative period. Analyze historical alert data for similar metrics to understand past incident impact, and then set an initial threshold that is informed by this data, followed by a period of observation and refinement based on actual performance and team feedback. Option C. Implement the proposed 70% CPU utilization threshold immediately, as it is a widely recognized industry standard, and assume it will be effective for all applications. Option D. Configure the alert to trigger only when the CPU utilization exceeds 90% for an extended period, prioritizing the avoidance of any alert unless absolutely critical, and instruct the operations team to perform daily manual checks of CPU performance. The correct answer is B. Establish a baseline of normal CPU utilization for the application over a representative period. Analyze historical alert data for similar metrics to understand past incident impact, and then set an initial threshold that is informed by this data, followed by a period of observation and refinement based on actual performance and team feedback. Explanation. Scenario analysis. This scenario presents a common challenge in IT operations, balancing proactive performance monitoring with the potential for alert fatigue and resource contention. The core difficulty lies in determining the optimal threshold for critical alerts without missing genuine issues or overwhelming the operations team. A poorly configured threshold can lead to either missed critical events, impacting service availability and potentially violating service level agreements, SLAs, or a deluge of non-actionable alerts, hindering the team's ability to respond effectively to real problems. This requires a deep understanding of the application's behavior, the business impact of performance degradation, and the capabilities of IBM Tivoli monitoring IBM v6. 3. Correct approach analysis. The correct approach involves a phased, data-driven methodology. It begins with establishing baseline performance metrics during normal operating conditions. This baseline serves as a reference point for identifying deviations. Next, it involves analyzing historical alert data to understand the frequency and impact of past incidents related to the chosen metric. This analysis helps in setting an initial threshold that is sensitive enough to detect anomalies, but not so sensitive that it generates excessive false positives. Crucially, this initial threshold is then validated through a period of observation, allowing for fine-tuning based on real-world performance and team feedback. This iterative process ensures that the threshold is both effective in identifying critical issues and manageable for the operations team, aligning with best practices for IT service management and ITIL principles, which are implicitly supported by the operational focus of ITM. This approach prioritizes accuracy and actionable intelligence, minimizing the risk of service disruption and ensuring efficient resource utilization. Incorrect approaches analysis. Setting an arbitrary, overly aggressive threshold without establishing a baseline or analyzing historical data is professionally unacceptable. This approach ignores the actual behavior of the system and the business context, leading to a high probability of alert fatigue. The regulatory or ethical failure here is a lack of due diligence in system management, potentially leading to missed critical events that could impact service availability, a violation of implicit service level commitments. Ignoring the impact of the alert on the operations team and setting a threshold based solely on technical possibility rather than operational reality is also professionally unsound. This can lead to burnout and a decreased ability to respond to genuine emergencies, indirectly impacting service delivery and potentially violating the principle of providing a reliable service. Failing to periodically review and adjust the alert threshold based on observed performance and operational feedback represents a static and reactive approach. Systems evolve, and performance characteristics can change. Without regular review, a once effective threshold can become either too sensitive or not sensitive enough, leading to the same issues of alert fatigue or missed incidents. This lack of continuous improvement is a failure in proactive system management. Professional reasoning. Professionals should adopt a data-driven, iterative approach to configuring monitoring thresholds. This involves understanding the system's normal behavior, the business impact of deviations, and the operational capacity of the response team. The process should be iterative, with initial configurations validated and refined through observation and feedback. This ensures that monitoring is effective, actionable, and sustainable, aligning with the goals of IT service management and ensuring the reliable operation of the monitored environment. Question 17. The audit findings indicate that the current configuration of IBM Tivoli monitoring v6.3 may not be adequately capturing and alerting on critical security events, potentially leaving the environment vulnerable to undetected intrusions or policy violations. Considering the need for precise and actionable security alerts, which of the following configuration strategies would best address this audit finding while adhering to best practices for effective monitoring? Option A. Increase the polling frequency for all system resources and enable verbose logging for every Tivoli enterprise agent to ensure maximum data capture, regardless of event criticality. Option B. Disable monitoring for certain low-volume security event logs that are not currently triggering alerts to reduce system load and simplify the console view. Option C. Implement custom event correlation rules within IBM Tivoli monitoring v6.3 to aggregate related security events and trigger alerts only when a predefined pattern of suspicious activity is detected, alongside configuring specific thresholds for critical security event sources. Option D. Rely solely on the default, out-of-the-box event policies provided with IBM Tivoli monitoring v6.3 without any customization, assuming they cover all potential security threats. The correct answer is C. Implement custom event correlation rules within IBM Tivoli monitoring v6.3 to aggregate related security events and trigger alerts only when a predefined pattern of suspicious activity is detected, alongside configuring specific thresholds for critical security event sources. Explanation. The audit findings indicate a potential gap in how IBM Tivoli monitoring v6.3 is configured to alert on critical security events. This scenario is professionally challenging because it requires a deep understanding of both the Tivoli monitoring product's capabilities and the underlying security principles it's meant to enforce. The challenge lies in translating abstract security requirements into concrete, actionable monitoring configurations that are both effective and efficient, avoiding alert fatigue while ensuring no critical events are missed. The need to balance comprehensive coverage with resource utilization is a constant professional consideration. The correct approach represents best professional practice because it directly addresses the audit finding by leveraging the specific features of IBM Tivoli monitoring v6.3 designed for event correlation and threshold-based alerting. By configuring specific event sources and defining precise thresholds for security-related events, the system can proactively identify and report on anomalies that might indicate a security breach or policy violation. This aligns with the principle of least privilege and robust security posture management, ensuring that monitoring is focused on what matters most for security. This proactive stance is crucial for maintaining system integrity and compliance. An incorrect approach that focuses solely on increasing the volume of alerts without intelligent filtering or correlation would lead to alert fatigue. This is professionally unacceptable as it diminishes the effectiveness of the monitoring system, making it difficult for security personnel to identify genuine threats amidst a flood of noise. This failure to prioritize and contextualize alerts can result in missed critical events, a direct contravention of the goal of effective security monitoring. Another incorrect approach might involve disabling certain security-related event sources due to perceived low criticality, which is a significant ethical and professional failure. This decision, if not rigorously justified and documented, opens the system to vulnerabilities that could be exploited, undermining the fundamental purpose of monitoring and potentially leading to data breaches or system compromise. A third incorrect approach could be to rely on generic, out-of-the-box configurations without tailoring them to the specific security policies and risk profile of the organization. This lack of customization means that the monitoring might not be sensitive enough to detect organization-specific threats or policy violations, rendering it ineffective and failing to meet the organization's security objectives. The professional decision-making process for similar situations involves a systematic approach. First, thoroughly understand the audit finding and its implications. Second, consult the IBM Tivoli monitoring v6.3 3. Documentation to identify relevant features and capabilities for addressing the specific issue. Third, collaborate with security stakeholders to define clear, measurable objectives for the monitoring configuration. Fourth, design and implement a solution that balances effectiveness, efficiency, and resource utilization. Finally, continuously review and refine the configuration based on operational feedback and evolving security requirements. Question 18. Process analysis reveals that the IBM Tivoli monitoring V6.3 environment is experiencing intermittent slowdowns in data collection and reporting, impacting the ability to accurately assess system health. Users are reporting delays in alert notifications and slower response times when accessing the Tivoli Enterprise portal. What is the most effective initial approach to diagnose and resolve these performance issues? Option A. Begin by reinstalling the Tivoli Enterprise portal server and all Tivoli agents to ensure a clean slate and eliminate potential software corruption. Option B. Systematically investigate the health and resource utilization of the Tivoli Enterprise portal server, TEPS, Tivoli Enterprise Console Server, TEX, Tivoli Management Server, TMS, and the status of critical Tivoli agents, while reviewing relevant system and Tivoli logs for errors or unusual activity. Option C. Immediately restart all Tivoli monitoring services across the environment to clear any potential temporary glitches and restore normal operation. Option D. Focus exclusively on optimizing the network connectivity between the Tivoli Enterprise portal server and the Tivoli Enterprise portal clients, as this is the most common cause of slow reporting. The correct answer is B. Systematically investigate the health and resource utilization of the Tivoli Enterprise portal server, TEPS, Tivoli Enterprise Console Server, TEX, Tivoli Management Server, TMS, and the status of critical Tivoli agents, while reviewing relevant system and Tivoli logs for errors or unusual activity. Explanation. Scenario analysis. This scenario presents a common challenge in IT operations where a critical monitoring system, IBM Tivoli Monitoring V6.3, is experiencing performance degradation. The challenge lies in diagnosing the root cause of the performance issues while ensuring minimal disruption to ongoing business operations that rely on the monitoring data. The pressure to restore full functionality quickly, coupled with the potential impact on service-level agreements, SLAs, and regulatory compliance, if applicable to the monitored systems, necessitates a systematic and informed approach. The complexity of Tivoli monitoring, with its various components like agents, the Tivoli Enterprise Portal TEP, and the Tivoli Enterprise Console TEC, adds to the diagnostic difficulty. Correct approach analysis. The correct approach involves a methodical investigation of the IBM Tivoli Monitoring V6.3 infrastructure, starting with the most probable causes of performance degradation. This includes examining the health and resource utilization of the Tivoli Enterprise Portal Server, TEPS, and the Tivoli Enterprise Console Server, TEX, as these are central to data aggregation and event management. Verifying the status and resource consumption of the Tivoli Management Server, TMS, and the Tivoli agents is also crucial, as agent issues can cascade and impact server performance. Reviewing system logs on both the Tivoli servers and the monitored endpoints for errors or unusual activity provides essential diagnostic clues. Finally, consulting IBM's official documentation and knowledge base for known issues and troubleshooting guides ensures that the investigation is aligned with vendor best practices and supported solutions. This comprehensive, layered approach, prioritizing core components and leveraging vendor resources, represents best professional practice by ensuring thoroughness, efficiency, and adherence to established troubleshooting methodologies. Incorrect approach is analysis. One incorrect approach is to immediately assume a network issue without first verifying the health of the Tivoli monitoring servers themselves. This is professionally unacceptable, as it bypasses critical diagnostic steps and could lead to wasted time and resources chasing a phantom problem. It fails to acknowledge the internal dependencies of the Tivoli monitoring system. Another incorrect approach is to restart all Tivoli monitoring services randomly without a clear understanding of the potential impact or a specific hypothesis. This is a brute force method that can disrupt ongoing monitoring, potentially leading to data loss or missed critical events, and does not address the underlying cause. It demonstrates a lack of analytical rigor and a disregard for operational stability. A third incorrect approach is to focus solely on the TEP client performance without investigating the server-side components. While TEP responsiveness is a symptom, it is not necessarily the root cause. Neglecting the TEPs, techs, and agent health means the actual problem, which could be server overload or agent malfunction, remains unaddressed. This approach is professionally flawed because it treats a symptom as the disease. Professional reasoning. Professionals facing such a situation should employ a structured troubleshooting methodology. This typically involves 1. Problem definition, clearly understanding the reported symptoms and their impact. 2. Information gathering, collecting logs, performance metrics, and system configurations. 3. Hypothesis generation, developing plausible explanations for the observed issues. 4. Testing hypotheses, systematically verifying or refuting hypotheses through targeted checks and diagnostics. 5. Root cause identification, pinpointing the fundamental reason for the problem. 6. Solution implementation, applying the appropriate fix. 7. Verification, confirming that the solution has resolved the issue and prevented recurrence. 8. Documentation, recording the problem, solution, and lessons learned. This systematic process, combined with leveraging vendor-specific knowledge bases and best practices, ensures efficient and effective problem resolution while minimizing operational risk. Question 19. Research into the most effective strategy for deploying IBM Tivoli monitoring v6. 3 agents across a diverse enterprise environment to ensure comprehensive system and application performance visibility without negatively impacting resource utilization. Option A. Deploy agents solely based on the availability of installation packages, assuming default configurations will provide adequate monitoring and resource management. Option B. Prioritize the installation of agents that collect the most granular data, disabling collection for less critical metrics to manage resource overhead, and address event correlation later. Option C. Install all available monitoring agents on every managed system to guarantee complete data coverage, and then individually tune agents if performance issues arise. Option D. Conduct a thorough assessment of each system and application's monitoring requirements. Select only the necessary agents, and configure their data collection intervals and filtering based on performance impact analysis and operational needs before deployment. The correct answer is C. Install all available monitoring agents on every managed system to guarantee complete data coverage, and then individually tune agents if performance issues arise. Explanation. This scenario presents a professional challenge related to the implementation and configuration of IBM Tivoli monitoring, IBM v6. 3. Specifically concerning the management of monitoring agents and their associated data collection policies. The core difficulty lies in balancing the need for comprehensive performance data with the potential impact on system resources and the adherence to established operational guidelines. Careful judgment is required to ensure that monitoring is effective without becoming a performance bottleneck or violating any implicit or explicit service level agreements, SLAs, or internal IT policies that govern resource utilization. The correct approach represents best professional practice because it prioritizes a systematic and controlled deployment of monitoring agents. This involves understanding the specific requirements of the applications and systems being monitored, selecting appropriate agents, and configuring them with optimized collection intervals and data filtering. This methodical process ensures that monitoring is targeted, efficient, and minimizes overhead. It aligns with principles of sound IT operations management, which emphasize proactive planning, risk mitigation, and resource optimization. From a regulatory or compliance perspective, while this specific exam doesn't mandate external regulations, adherence to internal IT policies and best practices for system stability and performance is paramount. This approach demonstrates due diligence in managing IT infrastructure. An incorrect approach that involves deploying all available agents indiscriminately without prior analysis or configuration would be professionally unacceptable. This would likely lead to excessive resource consumption, CPU, memory, network bandwidth, on the monitored systems and the Tivoli Enterprise Portal TEPS server, potentially degrading application performance and impacting service availability. This failure to assess impact and optimize configuration violates fundamental IT operational principles and could lead to service disruptions, which, in a regulated environment, could have significant compliance implications if SLAs are breached. Another incorrect approach, such as disabling data collection for critical performance metrics to reduce overhead, would also be professionally unacceptable. This would render the monitoring system ineffective for its primary purpose, identifying and diagnosing performance issues. It would create blind spots in system visibility, making it impossible to detect problems before they escalate, thereby failing to meet the objectives of performance monitoring and potentially violating internal IT governance policies that mandate adequate monitoring coverage. A third incorrect approach, focusing solely on agent installation without considering the Tivoli Enterprise Console, tech, integration, or event forwarding rules, would be incomplete. While agents collect data, the value of ITM lies in its ability to correlate events and generate actionable alerts. Neglecting the event management aspect means that the collected data, even if efficiently gathered, might not be effectively translated into meaningful insights or timely notifications, thus undermining the overall purpose of a monitoring solution. The professional decision-making process for similar situations should involve a phased approach. 1. Understand the monitoring objectives and scope. 2. Identify the systems and applications to be monitored. 3. Research and select the most appropriate ITM agents for the identified targets. 4. Configure agent parameters, including collection intervals and data filtering, based on performance impact assessments and operational requirements. 5. Plan for integration with event management systems, like TEC, and define alert thresholds and escalation policies. 6. Implement monitoring in a controlled manner, starting with a pilot group if possible. 7. Continuously review and optimize agent configurations and data collection policies based on observed performance and evolving needs. Question 20. The control framework reveals that the IBM Tivoli Monitoring v6.3 environment is generating a high volume of alerts, impacting the efficiency of the operations team. The team is considering two primary strategies to address this: either enabling all available monitoring probes to ensure comprehensive coverage, or selectively disabling alerts for components deemed less critical to reduce noise. Which approach best aligns with effective operational management and proactive incident response within the context of IBM Tivoli Monitoring v6.3 fundamentals? Option A. Enable all available monitoring probes to ensure maximum visibility and capture every potential anomaly, regardless of its immediate perceived importance. Option B. Focus on manual log analysis for all components, as automated alerts can be unreliable and lead to excessive noise. Option C. Disable alerts for components identified as non-critical without further analysis, assuming their failure will not significantly affect core business functions. Option D. Implement a tiered alert strategy, categorizing alerts by severity and potential business impact, and configuring thresholds accordingly to prioritize critical events. Correct answer is D. Implement a tiered alert strategy, categorizing alerts by severity and potential business impact, and configuring thresholds accordingly to prioritize critical events. Explanation: the control framework reveals a common challenge in IT operations, balancing proactive monitoring with the potential for alert fatigue. In the context of IBM Tivoli Monitoring v6.3 fundamentals, understanding how to configure and manage monitoring agents and their associated alerts is crucial for maintaining system stability and performance without overwhelming the operations team. This scenario is professionally challenging because an improperly tuned monitoring system can lead to missed critical incidents or wasted resources investigating non-issues. Careful judgment is required to define appropriate thresholds and alert severities. The correct approach represents best professional practice by focusing on a tiered alert strategy that prioritizes critical events. This aligns with the principle of efficient resource allocation and timely incident response, which are implicit in maintaining a robust IT infrastructure as expected by operational best practices and potentially by service-level agreements, SLAs, that would be governed by general IT service management frameworks. By categorizing alerts based on their potential impact, operations teams can focus their immediate attention on high-severity issues, thereby minimizing downtime and ensuring business continuity. An incorrect approach that focuses solely on enabling all possible alerts without differentiation fails to acknowledge the reality of alert volume and the human capacity to respond. This can lead to alert fatigue, where critical alerts are overlooked amidst a flood of less important notifications. This is a regulatory/ethical failure, because it can indirectly lead to noncompliance with operational standards or SLAs due to delayed or missed incident resolution. Another incorrect approach that involves disabling alerts for non-critical components without a clear understanding of their interdependencies is also professionally unacceptable. This can result in a lack of visibility into potential cascading failures or subtle performance degradations that could eventually impact critical services. This represents a failure in due diligence and risk management, potentially violating internal policies or industry best practices for system monitoring. The professional reasoning process for similar situations should involve a thorough assessment of each monitored component's criticality to business operation. This includes understanding the potential impact of failures or performance issues for each component. Subsequently, monitoring thresholds and alert severities should be configured based on this criticality assessment, with a clear escalation path defined for different alert levels. Regular review and tuning of monitoring configurations are essential to adapt to changing system landscapes and operational needs.